Today I will represent one of Prep 3's second term geometry branch lessons. It's the second lesson at Unit 4. The title of the lesson is Position of point and a straight line with respect to a circle. Position of point and straight line with respect to a circle. If you have a circle in a plan, the circle will divide the plan into three parts: outside, inside, and on the circle. If you draw the point A, outside the circle, then the line segment NA, the length of line segment MA will be more than the length of the radius. If you draw the point A inside the circle like that here, then the line segment or the length of line segment MA will be less than the length of the radius, as you see here. And if you draw the point A on the circle, then the length of line segment MA will be equal to the length of the radius. So we have three cases: outside, A outside the circle, A inside the circle, A on the circle. A outside the circle, MA will be more than the radius. A inside the circle, MA will be less than the radius. A on the circle, MA or the length of MA equal to the length of the radius. The second thing, or the second point we will speak about today in this lesson, it's position of a straight line with respect to a circle. The last one was about point, but that is about straight line. In the case of straight line, if the point A if the straight line L outside the circle, then the length of MA is more than the radius. You can notice that here that the straight line L is perpendicular to the line segment MA in three cases. So if we have a straight line and a radius or radius and extension of radius, if the both of them are perpendicular, then if L outside, then MA will be more, the length of MA will be more than R. So that's R. So you can note that MA more than R. If MA equals the radius, then L will touch the circle in the point of tangency, or in one point. This point we call it the point of tangency, and the straight line L we call it tangent. So if MA equals the radius, the straight line we call it tangent, and the point the point A, we will call it the point of tangency. You can note that the line sigma, the straight line L, touch the circle just in one point. But in that case, the third case, he touch the straight line L will touch or will touch the circle in 2 point and will divide the circle into 2 parts. But in that case, we will call the straight line, it will denoted by, or we will call it a secant, because MA more than less than the R. MA, that's from this point to this point, we will it's MA, but from this point to this point it's R, so we can note that MA less than R. So in that case, the straight line L, we will call it secant. And this the chord XY, the formed chord XY from this point to this point, this chord, we will call it the chord of intersection, So we will do a quick review. When we will do a quick review, when MA more than R, then the line, straight line will be outside the circle. When MA equal R, then the straight line will be a tangent, and the point A will call it the point of tangency. When MA less than the R, then the straight line L will be a secant, and we will call the line segment XY the chord of intersection. Call a chord of intersection. The last point about the lesson of if the line if the line L is a tangent, then the radius MA is perpendicular to L. The radius MA will be perpendicular. Okay, and the second fact, if the radius MA is perpendicular to L, you can note that MA is a radius and perpendicular to L, then L will be a tangent. So if L a tangent, then there are a radius and perpendicular. If MA radius and perpendicular to L, then L will be a tangent. That's all for today. You can subscribe our channel and like this video and share it, or you can follow us on our page on Facebook, Mr. for Math. And if you want to ask me any question, you can send me or ask at our group on Facebook, Mr. My Math is okay, and goodbye.